So we've already talked about horizontal asymptotes, and we know that the big thing with horizontal asymptotes is the degrees. So, and we know the three scenarios. We know that if the degrees are the same, we take a look at the ratio of leading coefficients. We know that if the degree of the numerator is larger than the denominator, there is no horizontal asymptote. And we know if the degree of the numerator is smaller than the degree of the denominator, then we have a horizontal asymptote at 0. So horizontal asymptotes, all about degrees. In this video, we're going to learn about something called a slant asymptote. And even though whenever the degree of the numerator is bigger than the degree of the denominator, we never have a horizontal asymptote, in some cases, we will have a slant asymptote. And just to give you an idea of what a slant asymptote would look like, so let's just say that this is your coordinate plane here, and your slant asymptote would look something like this. So notice that you do not have the horizontal asymptote. You don't have this. You have something that's kind of has a slope, and it's a slant asymptote. A rational function that has a numerator exactly 1 degree greater than the denominator has a slant asymptote. Let me give you an example. So let's say that let's say that up here I have x to the 4th plus x to the 3rd minus 2x squared minus 17. The degree of my numerator in that case would be 4. If my denominator is something like this, x to the 3rd minus 5x squared plus 8, that would have a slant asymptote because the degree of my numerator is 4. It's always my largest exponent. The degree of my denominator is 3. Therefore, the degree of the numerator is exactly 1 degree greater than the denominator. Whenever you want to find your slant asymptote, the big idea is we need to use long division. You would just divide your numerator by your denominator, and there you have it. You'll have exactly where your slant asymptote is. Let me show you an example involving that. So this example says, first off, we just need to decide whether each of the following rational functions has a slant asymptote. If so, find the equation of the slant asymptote. Now, let me just move this stuff up here a little bit, give myself some room to work. All right, so let's first off just focus on those degrees. In this function, the degree of my numerator is 3. The degree of my denominator is 2. So I am going to say yes. This function will have a slant asymptote. And we'll calculate that in a second. Let's just take a look at if part B would have a slant asymptote. The degree of my numerator is 3. The degree of my denominator, that would be 2x to the 1st right there. So the degree of my denominator would be 1. Notice that it's bigger. The degree of the numerator is larger, but it's not 1 larger. This degree down here would have to be a 2. That would have a slant asymptote. Or if this 3 right here was a 2, then I would have the numerator with the degree 1 larger than the denominator. So this one's out. There is no slant asymptote here. All right, now let's actually calculate my slant asymptote here for this function. So I'm going to set up my long division. I got to do x cubed, and we can put some placeholders in here. So plus 0x squared plus 0x minus 1. And we are going to divide that by x squared plus 3x plus 5. And if you remember your steps with long division, first thing we're going to do is we're going to take x cubed divided by x squared. That would be x. I'm going to put x right there. And then I'm going to multiply x by this trinomial here, x times x squared. That's x cubed. X times 3x, that would be 3x squared. x times 5 would be plus 5x. And remember that I'm going to subtract all of this stuff. Subtract that group. X cubed minus x cubed. Those cancel out. That should happen every single time. Nothing up here minus this 3x squared. So this will be negative 3x squared. Nothing here minus 5x. That's minus 5x. And let's just bring this negative 1 straight down. We're going to go through the process again. I'm going to pick a new color here. I'm going to take negative 3x squared divided by x squared. That would give me negative 3. And let's multiply this out. Negative 3 times x squared is negative 3x squared. Negative 3 times positive 3x would be minus 9x. Negative 3 times positive 5 would be minus 15. And let's subtract. So we're going to subtract this whole group of stuff. So negative 3x squared minus negative 3x squared. Well, that's the same thing as adding. Subtracting a negative is adding. Negative 3x squared plus 3x squared, those are going to cancel out. Negative 5x minus negative 9x. That's the same as negative 5x plus 9x. So that would give me 4x. And negative 1 minus negative 15 would be the same as negative 1 plus 15, which would be plus 14. And at this point, because my degree here is lower or smaller than my degree of my divisor, I know that this is actually my remainder. And with this problem, we don't even really need that. So we know that if I divide x cubed minus 1 by x squared plus 3x plus 5, the exact answer with remainder would be x minus 3 plus 4x plus 14 all over x squared plus 3x plus 5. But the key here is this. If I just take that quotient and realize and set y equal to that, that tells me exactly where my slant asymptote is. My slant asymptote is the line y equals x minus 3. Just to do a quick sketch, that means that my y-intercept would be negative 3, and my slope would be positive 1. And just as a very rough sketch here, slant asymptote would look something like that. Just to pull my answer here. So yes, we have a slant asymptote, and it is at y equals x minus 3.